Hello everyone, for today's lecture video about atoms, molecules, and ions, we'll be having its part 2.1. Let's start. For the learning objectives, we'll be having, under part 2, name and write chemical formulas of compounds. Again, apologies for the ambient noises that you may be hearing or will be hearing along the way. Okay, apologies for that one. But nonetheless, for today's topic outline, we actually have the following. We need to name certain compounds, particularly ionic and covalent. Chemical nomenclature. Now, do not be enamored by the word chemical nomenclature. When we say chemical nomenclature, in a much more easier sense, that really means chemical naming. Sa madaling salita po, pagpapangalan lang po ng compound or pagpapangalan lang po ng certain substances. Okay? Let's start with naming ionic compounds. Now, under ionic compounds, there is a classification. The first thing is your binary ionic compounds. Now, when we see binary ionic compounds, so these are ionic compounds consist of two elements, a metal and non-metal. So let's write that one. So when we say binary ionic compounds, these are your ionic compounds consist of metal plus a non-metal. So let this be a definition. When we say ionic compound, an ionic compound is made up of metal and non-metal. So when you see a particular compound containing a metal and then a non-metal, you call it as an ionic compound. Okay? Now, how to name binary ionic compounds? First is to name the cation. Now, metal cations take their names from the elements. So, whatever the name of the particular metal or the particular cation, that will be its first name, okay, or the first component of the chemical nomenclature. Second, name the anion. Now, the anion is named by taking the first part of the element name and adding the suffix IDE. Your anion or nonmetal, your second component, we will take the first part of the element name and add a suffix IDE. Therefore, we have this certain format. So we actually have cation plus anion IDE. So we just simply follow this format. This is entirely easy. Examples. We have here NaCl. Na is sodium. So my first name for that particular ionic compound is sodium. So example, NaCl. Na is sodium, that is your metal. And the non-metal chlorine, I will take the first name and then add IDE, chloride. Therefore, this will be my answer for NaCl. What about MgBr2? Again, as the format suggests, name of the cation. My cation is Mg or my metal is Mg. The name of this one is magnesium. And then second format, anion IDE. My anion or non-metal is Br. So that's actually bromine. So I'll be taking the first part of the element's name, that is bromine. So brom, and then I will add the suffix IDE, bromide. Therefore, this will be my answer for MgBr2 as the name magnesium bromide. Same thing with Al2O3. This will be aluminum oxide. Okay, just remember the format. You have cation plus anion and then prefix IDE. Okay, easy, very easy. Now, what about the examples? Now, these are just more examples on how to name binary ionic compounds. So let us discuss them. Again, remember the format. Let me write again the format so that we have a guide. So we need to have your cation plus anion and then the IDE. Or another form is your metal plus non-metal and then IDE. Okay, either of the two, we can actually use them as format. AlBr3, so I could name this one as aluminum, the first element, and then second one is bromine, adding IDE, aluminum bromide. Number 2, I have Ca3P2. Ca, looking at your maybe at your periodic table. So let us just load the periodic table here. Um, Ca is this one. As you can see in the projected screen, you have calcium. So I will be having to name it as calcium. Okay. And then P2, letter P or the element P. Looking at the periodic table once again, that is phosphorus. So I will name it as, following the format, I have phosphide. Okay, IDE. Next, SRI2. So I will need to find the word or the name for SR, for the element symbol SR. SR is this one. That is strontium. So I will write strontium here. Strontium. And then the second component is I. So looking back at the periodic table, I is actually this one. So iodine. So I will take the first name and then add as a suffix IDE. That will be iodide. Strontium iodide. Okay? So for the following, you have AlBr3. The name is aluminum bromide. So AlBr3. And then calcium phosphide, you have Ca3P2. Strontium iodide, you have SrI2. Okay? So a key help for you is to have a periodic table with you so that you would know the name of the particular element looking at their symbol. So for example, strontium. So you just look for Sr. So this is Sr. So strontium. Look for I. You have iodine. Look for Ca. That's actually calcium. Look for P. That's phosphorus. Aluminum. Al. And then Br. That's bromine. Here at this particular part, where is bromine here? Yeah, this one. Br bromine. Okay? Okay. Next one, we need to know or we need to identify and name another form or another format in chemical nomenclature or naming, particularly metals with variable charges. We are still under the classification for ionic compounds. Now, what if we have metals with variable charges? Meaning to say, your cation and your metal, cation or metal, has different charges or variable charges. Look at the first point. Certain metals, especially the transition metals, have more than one charge. Sa madaling salita po, meron po kasi mga cation o mga metal na higit pa sa isa yung kanilang charge. Ibig sabihin, hindi lang plus 1, hindi lang plus 2, hindi lang plus 3 ang kanilang mga naging charge. Okay? Ano pong example nun? Example po ay ito. Tulad nito, yung mga nasa transition metal, tulad ni, ni iron, Fe, siya po ay mayroong 2 at 3, positive 2 at 3. Ang tawag po kay iron ay metals with variable charges. Ibig sabihin, higit pa sa isa ang kanyang charge. Dahil higit pa sa isa ang kanyang charge, may iba pang uri ng pagpapangalan kapag may involved na iron. Tulad din kay titanium, vanadium, chromium, ganyan. May ibang uri ng pagpapangalan. And that is the thing that I'll be discussing. When naming compounds involving metals with variable charges, the charge associated with the metal cation in the compound must be determined. Meaning to say, if we're going to name a metal with variable charges, we need to identify the use or the particular charge that was held in that particular compound. Kailangan po natin ma-deduce, kailangan po natin malaman kung ano yung charge na ginamit upon creation or upon combining of that particular compound. Let us explain further. Now, here are some of the examples, like iron has Fe2+, Fe3+, copper, cobalt, tin, mercury, lead. Now, these are just some of the examples of metals with variable charges, meaning to say, again, as mentioned earlier, metals who have more than one charges, and they have a particular way of naming them. Now, let's start. Now, we are now in naming ionic compounds. Okay, ionic compounds with variable charges. Okay? Now, there are two ways on how we can name ionic compounds with variable charges or metals with variable charges. Okay? The first way is what we call the stock system. Okay? Let me first explain what stock system is. Stock system. The first way is that we need to determine the charge of the metal in the compound. We need to identify what charge does the metal hold. Okay, your first element in the name. Name the metal followed by a Roman numeral in parentheses immediately following the name of the metal. The Roman numeral represents the charge of the metal. Name the nonmetal with the ending IDE. So in short, we can have this following format. So in the SOC system, we can actually have cation, okay? Cation, or we can actually name this one as metal. And then you have here the Roman numeral, okay, Roman numeral, plus an ion or your non-metal, and then IDE. So this will be your format when we name ionic compounds with metal with variable charges using the stock system. Okay? Again, this is your first way on how to name ionic compounds with metal charges. Okay, metal with variable charges, the stock system. The format is cation or metal, then followed by the Roman numeral plus an ion non-metal IDE. Let me give you an example. Let us name FeCl3. Now to name FeCl3, we need to deduce, again, the first step is determine the charge of the metal. Now, how do we do that? We simply deduce, okay, or simply identify the charge. So we can actually deduce it by using this one. Now, to form FeCl3, we have Fe and chlorine. Okay? To easily identify what charge iron has originally, let us look at the charge of chlorine. So going back at this particular periodic table having their oxidation state, let us look at chlorine. Now, chlorine here acts as an anion. Remember, when we say anion, they have negative charge. Now, look at chlorine at the table. The negative charge for chlorine is -1. Ulitin ko po. Ang function ni chlorine kay FeCl3 ay anion. Naalala natin, pag sinabing anion ay negative. So, tignan sa periodic table kung anong oxidation state value o nagsasabi o na nagpapakita ng pagka-negative. Kay Cl or chlorine, -1. So, I will put or I will deduce that chlorine started o nagsimula bago sila mag-combine, okay? Cl negative pa siya. Ngayon, dahil natutunan natin na nabobuo ang or sa pagsusulat ng ionic compound, ginagawa natin ay criss-cross. Now, assuming itong -1 ay nag-cross papunta kay Fe ay naging 1, okay? Kaya itong negative ay naging Fe siya, nung nag-criss-cross, ano kayang charge ni Fe or ni ion para maging Cl3 itong sagot? Now, looking at the oxidation state, Fe, iron has two possible charges, 2 and 3. Sa tingin mo ba, kung 2 positive ang nilagay mo dito, pag nag-criss-cross ka dyan, ang magiging sagot ba ay FeCl3? Sige, i-criss-cross natin. Criss-cross, you have FeCl2. Mukha bang FeCl3 ito? Hindi. So that means, this must be, or the charge or the original charge of Fe must be 3 positive. Ngayon, pag kinriss-cross mo sila, you now have FeCl3, which is your first or original given, FeCl3. Okay? Okay, so that is how you may deduce your particular metal charge. Okay, so ngayon, nagawa natin sa number 1. Alam natin na positive 3. Next, pwede na natin gawin itong format ng pagpapangalan. So therefore, FeCl3, I will get the name, iron, Roman numeral. The Roman numeral represents the charge. So ang charge ay 3. Roman or iron 3, and then non-metal, chlorine, plus IDE, chloride. Therefore, my final answer is iron 3 chloride. Okay? Easy, very easy. The part that may look challenging is this one. The part we need to deduce. Ang ginagawa po natin dito ay dinideduce natin or inaalam natin kung ano yung naging original charge. Kumbaga parang dinadissect mo pabalik. Kasi iisipin mo, paano naging FeCl3? Ano kaya yung mga naging superscript? Naalala niyo yun? Kung ano yung naging superscript or original charge nila bago sila nag-criss-cross. Kasi isipin mo, kung 2 plus yan, hindi naman magiging FeCl2 yan. Kaya that must be 3 plus. So, FeCl3. So, kung ano yung original charge of the metal, that will be your Roman numeral. Sige, another example. Okay, another example, CuS. So again, first step, we need to dissect this one, CuS. So again, look at the, what you call this one, the oxidation state. Let's start with sulfur, yung S. So look at sulfur. Si sulfur dito, kay CuS, acts like an anion. Remember, anion, so siya yung negative. Si Cu, siya yung positive. So hanapin yung charge ni S na negative. So negative 2, looking at the table. So I assume this will be negative 2. Okay, negative 2. Ngayon, ano kayang charge ni copper na magpuproduce ng CuS kapag nag-criss-cross na tong dalawa? So look at copper. So 2 at 1 lang naman ang possible. Sa tingin ba natin 1? I don't think so. Maybe, or I think so, it's 2 plus. Okay, so I think it's 2 plus. So try natin i-criss-cross. So criss-cross, criss-cross. So right now you have Cu2S2. But remember, whenever we write ionic compounds formula, we need it to have it in its empirical form or lowest term. So 2 and 2 could be in a much more lower whole number ratio, so we can write Cu2S2 into CuS. Therefore, we have the same particular empirical formula. Therefore, indeed, copper's or Cu's metal charge or variable charge is 2 plus. So therefore, I can now name the particular substance. So following this format, copper, Roman numeral 2, because that is the one we've determined. And then an ion, my sulfur, that will be sulfide. Copper 2 sulfide. Easy, very easy. Another example. Okay, let's have MnO2. MnO2. So look at the periodic table again. This particular periodic table. So again, we deduce it. We have manganese and oxygen. So looking at oxygen first, remember this is your cation and then oxygen is your anion. So look at oxygen. The charge for oxygen is negative 2. All right. So what must be the charge of manganese that at the end of the crisscrossing, the answer became MnO2. So look at Mn or manganese you have here. So manganese has several variable charges. You have 2, 3, 4, 6. Now, which among the choices could give us an answer of MnO2? Okay, I think for us to have MnO2 as the final answer, I think the charge used here is 4 plus. Let's check. So crisscross. So the answer here will be Mn2O4. Again, lowest term. I will put this into lowest whole number ratio. I have MnO2. 2 and 4 has a multiple of 2. So lowering them down in a whole number ratio, we have MnO2, which is the same with our given. Therefore, our particular charge for manganese is 4. Okay? Now, I can now name using the format. So that will be manganese. Okay? So Mn is manganese. This one. Yeah, manganese, Mn. Okay? So I can now name it's manganese. And then the Roman numeral is 4 because we've now discovered that it should be 4. 4 and then oxygen, so that will be oxide. This is your final answer. Okay? Easy, very, very easy. Next one. After dealing with the first way on how we name ionic compounds with variable charges using the stock system, the second way is what we call classical system. So we are now in the second mode or the second way on how to name ionic compounds, what we call the classical system. So from stock system, let's move forward with classical. Now, how do we name ionic compounds with metals with variable charges through classical system? Classical system, number one, assign the ending OUS or US to the cation with fewer positive charges and the ending IC or IC to the cation with more positive charges. This method of naming ions has distinct limitations. There are metallic elements can assume three or more different positive charges and compounds, thus it is more convenient to use the Roman numerals in naming metals with variable charges. What does that mean? Sige, explain ko po na mas madali itong number 2. Ang gusto ko sabihin nitong classical system ay, ito po ay medyo limited. Okay? Ibig sabihin po, best or maganda po gamitin itong paraan ng classical system kung ang metal with variable charges ay mayroong dalawang charge. Okay? Ulitin ko po. Maganda lang po gamitin ng classical system kung yung cation po or yung metal ay meron lang po dalawang variable charges. Ibig sabihin kung tatlo o higit pa yan, hindi po magandang gamitin tong classical. Mas magandang gamitin si stock system, okay? Yung nauna po natin, itong stock system, mas maganda ito gamitin tong stock system kung ang metal ay mayroong tatlo o higit pang charges. So si classical, best siya gamitin kung hanggang dalawa lang yung charges. Let me explain with a visual. So for example, kung yung metal mo ay cobalt, goods, sige, gamitin natin classical system na pamamaraan. Maganda siya kasi hanggang dalawa. Pero kung ang gagamitin mo or ang ionic compound mo ay tulad nito, may manganese, 2, 3, 4, 6 ang possible niyang variable charges. Mukhang hindi magandang gamitin sa classical system kapag papangalanan mo yung compound na mayroong manganese. Kasi, ayun no, 4 ang variable charges. Remember si classical, maganda lang siya, seemingly maganda lang siya gamitin kung si metal ay mayroong dalawang charge lang. E si manganese 4. Tulad din ni chromium 3. Medyo mahirap itong gamitin. Mas maganda sa stock para sa mga metal na 3 o higit pa. Pero either way, if you would be opting to use classical system for metal charges who has 2 charge, pwede din naman. Sige, I hope that is clear. Now let me explain how to do it. Now we have the format here. That is the original name or the origin name of the metal plus OUS plus an ion, IDE. We use OUS for lesser charge, yung mas mababang positive charge between the two. So, orig name, ito yung second format, name, metal, IC, plus anion, IDE. Let me explain further. Let me just write the format. Okay, so you have actually 2 formats here. Sige. Let me give you an example with FeO. Okay? FeO and Fe2O3. Again, looking back at the example here, iron is suitable. Pwede po si iron for classical system. Kung gagamitin nyo po ang classical system sa pagpapangalan kay FeO at Fe2O3, pwede. Kasi looking at iron, your cation, 2, 3. Dalawa lang ang kanyang metal charges. So pasok. Kasi basic classical system for metal with variable charges with 2 charge. Okay, so pwede. So go tayo dito. So again, the same format pa rin po tayo. We actually deduce first. We deduce first the elements. So FeO. Pareho silang FeO. Remember, iron is your positive. Oxygen is your negative. Okay? Now looking at the oxidation state, oxygen again has -2. So 2 negative. And then to negative. Ngayon, ano kayang charge ni iron na kapag kinriss-cross natin silang dalawa, si Fe tsaka si O, FeO ang lalabas sa sagot? Now, looking at the choices, 2 at 3 lang naman yan. Key FeO, this must be 2 plus. So, pag kinriss-cross mo yan, meron kang Fe2O2, and then lowest term, you have FeO. So, parehas na ngayon. Okay? So, ang ginamit natin dito ay 2 plus kay FeO. How about Fe2O3? Ano kayang charge ni iron na kapag kinriss-cross together with O2 negative ay magiging Fe2O3 ang sagot? Now, looking at the choices, 2 at 3 lang naman yan. Since nagamit mo na yung 2 dito, that must be 3. So, 3 plus. So, i-criss-cross mo na yan ngayon. You have Fe2O3, which is the same with your given. So, that means ang ginamit mo dito ay 3 plus. So, dito ay 3 plus, dito ay 2 plus ang iyong ginamit. Ngayon na na-discover mo na or alam mo na kung ano yung particular charge na ginamit. So, for FeO, 2 plus, kay Fe2O3, 3 plus. Now, we can now name FeO. So, original name. The original name for iron comes from the word Fe, no? Yung ferrous and ferric. Okay? Ferrum, actually. It's not ferrous and ferric. So, the original name for iron or Fe, I think, correct me if I'm wrong. Okay? Correct me if I'm wrong, okay? Fe is ferrum, I think. So, ferrum. So, yan. So, original name is ferrum. So, original name, metal plus OUS. Gagamitin mo po si OUS for lesser. Si IC or IC, gagamitin mo for greater charge. Sige, FeO at Fe2O3, alin ang mas mataas na charge? Or mas mababa rather? 2 or 3? Ang mas mababa ay itong 2, lesser. Si 3 plus, greater. So, itong lesser, ang susundan niyang format is format number 1. So, ngayon, susundan ko yan. Ferrum. I will put OUS. Ferrous. Anion, oxygen, oxide. 3 plus, being the greater than, kasi tignan mo naman yung 3. Mas malaki talaga sa 2 yan. So, I will have Fe2O3 as ferric, and then anion IDE, oxygen, oxide. So, therefore, this is my answer for the names of FeO and Fe2O3. Ferrous oxide and ferric oxide. Let me repeat. OUS ang ilalagay mong suffix kapag mas mababa. Ito, 2 plus, mas mababa yan. Fe2 plus. Ferric naman o IC ang gagamitin mo. Not ferric, but rather the suffix IC for the positive charge that is larger. Kaya po, ang challenge dito ay mas mahalaga o mas magandang mauna o malaman mo muna yung mga positive charge or yung mga variable charge. So, at this point, look at the process. Kailangan muna natin malaman yung charge ni Fe, yung metal with variable charge. So, knowing na 2 tsaka 3 sila separately. So, kung anumang compound ang nakakuha ng mas mababa, siya ang gagamit nitong OUS. Sa compound naman na nakakuha ng mas mataas, in this case 3 plus, siya yung gagamit ng IC. Okay? Okay. Another example. Sige. We have here Cu2S and Cus. Okay? Now again, we deduce it. So you have here copper and sulfur, copper and sulfur. So what must be the charge of sulfur again? So remember, your copper is your positive, cation, and then negative, positive, and then negative. So the charge for sulfur, as in an ion, is negative 2. Looking at the table, 2 negative. So copper, looking at copper, you have here, copper, 2 and 1 lang naman ang possible. So best, pwede siya. Pwede siyang classical system kasi dalawa. So ano kayang charge ni copper para maging Cu2S ang sagot? So I think that will be 1. Kasi pag kinriss-cross mo yan, you have Cu2S, which is the same with your given. So for Cu2S, ang particular charge na nagamit sa kanya ay 1 plus. Now for Cus, so ano kayang charge ni copper para maging Cus ang sagot? So between 2 and 1, I think that is 2 plus. So crisscross them, you have Cu2S2, and then lowest term them further, you have Cus, which is the same thing with the given. So therefore, the charge used for copper in Cus2 is 2 plus. Now following the format, now the original name for copper is cuprum. You can actually search them from the internet or even look at them at the back of your periodic table. May mga information sa likod po ng periodic table nyo like original name, you can look for it. So for copper, so 1 plus, siya ang gumamit ng mas mababang charge. So this must be cuprous and then sulfide. And Cus2, this must be the higher value. So I will have cupric sulfide. Cupric sulfide. So this will be the final answer for the particular substances. Okay? So hopefully things are clear on how we name. Again, we are just in naming ionic compounds with variable charges. So pag may nakita po kayong metal o cation na may mga variable charges, pili po kayo sa dalawa, stock system or classical. Pero just a recommendation, I really recommend to use stock system. Ito po, mas recommended ko na gamitin nyo itong stock system kasi Roman numeral na. Kasi kung ano na yung kung ano yung naging charge ni cation, lalagay mo na lang. Kung 3 yan, di 3 lagay mo dyan. You won't be having difficulty to identify the origin name, the original name, and stress about kung alin yung gagamitin ng OUS or IC. Ayan. Kasi itong classical, best lang siya kung yung metal ay hanggang 2 variable charge lang. Pero kung stock system, kahit ilan yan. Okay, but that's just my recommendation. Okay? Okay. Next one. Now, next under the ionic compounds, we have here ternary ionic compounds. Now, ternary ionic compounds. Now, what about ternary ionic compounds? Let me explain this one. Ternary compounds are composed of 3 or more different elements. The most common types of ternary ionic compounds consist of the metallic cation and polyatomic ion. Now, this simply means that ang ternary ionic compounds po ay uri ng ionic compounds kung saan gawa sa isang metal or metallic cation plus isang polyatomic ion. Okay? Remember polyatomic ion, these are clumps of ions. Examples of ternary or common polyatomic, ito po yung mga common polyatomic. You have acetate, ammonium, carbonate, chlorate, chloride, chromate, cyanide, then so on and so forth. On your periodic table, you can actually see common polyatomic ions at the bottom part of your periodic table. Nasa bandang ilalim po yan. Okay, makikita nyo yung listahan ng mga polyatomic ion, both for positively charged and negatively charged. But then again, to name ternary ionic compounds, you have a metallic cation and then the polyatomic ion. Let me explain further on how to name them. Now, how to name ternary ionic compounds? Now, simply name the cation, pangalanan po itong una. Metal cations take their names from the elements. If the cation is polyatomic, use the name of the ion. So kung anong pangalan po ng metal, yun na yun. Second, if the metal cation has a variable charge, indicate the charge by using a Roman numeral enclosed in the parentheses or use the OUS and IC. So ito po, kapag nagpapangalan ng ternary ionic compounds, papaalam ko lang po na may posibilidad na mayroong variable charge. Kasi nga itong unang component mo sa ternary ionic compounds ay metal. So ibig sabihin, pwede siyang may variable charge. Again, ito pong mga nasa unang element na yan na component, pwedeng manggaling na naman dito sa madaming charges. Kapag madaming charges, anong gagawin? Or kapag metals with variable charges, pwede kang mag-classical or stock system. Kaya nga nakalagay dun sa instruction, so going back with the PowerPoint, if the metal cation has a variable charge, basta mayroong variable charge, it's either mag-stock or mag-classical ka. Pero I really suggest use the stock system na lang. And then third procedure, use the name of the polyatomic ion. Sige, example. Actually, the format first. So the format, this will be your format on how to name ternary ionic compounds. You have there your cation or metal. Now, how do you name it? either stock or classical. Again, magsa-stock or classical ka lang naman kung yung metal ay may variable or may with variable charges. And then, na madali lang, yung second component, name lang na po ng polyatomic ion. Sige, example. Yan yung format ha. Example, KOH. Okay? So, cation ko ay K. So, looking at K, the name of K is potassium. Potassium yung K. Pero, wag muna akong bibilis din sa pagsasagot. Wag muna akong magmadali. Tignan ko muna kung may variable charge si K. So, looking at this oxidation state table, ito si K. Isa lang. At dahil isa lang ang kanyang charge or variable charge, no need. No need to do stock or classical. So, paalala po yun. Kapag po si metal ay isa lang naman ang kanyang charge, wag na po. Wag nang mag-stock or classical. Gamitin lang sa stock or classical kapag dalawa o higit pa. So, dahil isa lang naman yan, pangalanan ko lang. Lagay ko lang dyan ay potassium. Easy. And then second step, name of the polyatomic ion. Now, the polyatomic ion is actually what we call hydroxide. So, I will put hydroxide. Again, you can actually search for the name of OH in your content, or you can actually look for the name of OH on your periodic table at the bottom part. So, the answer here is potassium hydroxide. Ganun lang. Sige, another example. We have here CuSO4. Okay? Actually here, pinakita na dito. Ayan, ito yung example. Like this one, OH. Hydroxide. Okay? Potassium hydroxide. And since potassium here has 1, okay, we have, this will be positive 1. And then from the OH, has a charge of negative. So, pag kiniris-cross po natin yan, that will be KOH. Okay? So, no need na talaga mag-stock at classical. Sige, next one. You have here CuSO4. Sige, papangalanan natin to. So, alam natin, so, deduce muna natin, CuSO4. Copper and then SO4. Okay, SO4. Now, SO4 is sulfate. Now, looking at this table, we have your SO4, 2 negative. Ayan po, nasa PowerPoint. Sulfate SO4. So, I will write 2 negative. Ano kayang charge ni copper, nitong copper, para maging sagot ay CuSO4? So, looking at the oxidation state here, si copper 2 at 1 ang possible. So, sa tingin ba 1? I don't think so. I think the original charge used here is 2 positive. So, pag kiniris-cross natin yan, you have Cu2 and then SO4, 2. Pero ang final answer natin ay simplified. So this must be simplified further kasi pwede pang ma-lowest term itong mga subscript. So we have CuSO4. So ang ginamit pong charge kay Cu ay 2+. At dahil variable charge si copper, gagamit ako ng stock or classical. Pero para mas madali, stock ang gagamitin ko. So the name of this one is copper 2. So, polyatomic ion. Ang pangalan ng SO4 ay sulfate. So, copper 2 sulfate. So, let me check if tama ako. Copper 2 sulfate. Okay? Okay. Sige, another example. So, we have here number 3. So, for number 3, we have NaHCO3. So, Na is your metal. HCO3 is your anion. Ito yung polyatomic ion, HCO3. So let me just deduce them. So you have your Na and then HCO3. So looking back at the table, HCO3. Do we have HCO3? Yes, we have your bicarbonate. Ang charge ni bicarbonate, looking at the table, is negative. So I will put negative. Ngayon, tignan natin, anong charge kaya ni Na para maging NaHCO3 ang final answer. So, looking at Na at the oxidation state, Na, sodium. Ay, ang ganda, isa lang. So, 1. So, positive. So, pag kiniris-cross natin yan, you have NaHCO3. So, same. At dahil, looking at this one, sa sodium ay may isa lang naman charge, Okay? No need. No need to do stock or classical. Dahil isa lang naman in charge ni Na. So following the format, we have here, yan, following the format, I have sodium. No need to stock or classical dahil isa lang naman ang charge, positive 1. Sodium and then the name of HCO3 bicarbonate. So therefore, the name of this particular substance is sodium bicarbonate. Okay? Okay. Easy, very easy as long as you follow the format that I am introducing. Now at this point, we are now moving forward to a different kind of compound. We are now here in naming covalent compound. So, graduate na po tayo sa ionic, okay? Sa ionic po kasi ang medyo madami at kakaiba ang uri ng pagpapangalan. Pero kay covalent compound, let's see. Now, we are now naming covalent compounds. Now, let me define first what a covalent compound is. A covalent compound are composed of non-metallic elements. So, ibig sabihin po, covalent ang iyong compound kapag gawa sa dalawang non-metal. So kapag nakita mo na ang compound ay gawa sa dalawang non-metal plus non-metal, automatically covalent yan. Kung si ionic, metal plus non-metal, si covalent, non-metal plus non-metal. Okay? Now, naming binary covalent compound is similar to naming binary ionic compound. We simply write the name of the first element in the formula first and the second element with the name adding IDE. Napakadali lang. Parang tulad lang siya ng binary ionic compounds. In naming binary molecular compounds, we use Greek prefixes to denote the number of atoms of each element. So medyo may tweak lang ang differences. So let us follow this particular format. Okay, so I'm giving the format again para meron po ko yung, alam niyo po yung gagawin. So prefix, and then name of the first element, plus prefix, and then name of the second non-metallic element, and then IDE. Yan po yung format nyo. Prefix name plus prefix name IDE. Ano po yung mga prefix? Yung mga prefix po, ayan po. Yung mono, di, tri, tetra, penta, hexa, hepta, octa, nona, deca. For example, meron ka ditong H2O. So, ang una mong element ay hydrogen. Ang pangalawa mong element ay oxygen. So, prefix. Itong prefix po, paano mo malalaman kung alang prefix gagamitin mo? Tignan mo itong bilang ng atoms, itong subscript. So, si H may dalawa, H2. So, ang gagamitin mong prefix ay di. So, ito pwedeng dihydrogen. Yun yung format, prefix name, di, and then the name, hydrogen. Next, prefix name IDE, oxygen. So, prefix, dahil automatically kapag walang subscript ay yan ay 1, so pwedeng mono, and then the name, oxygen, and then IDE. Mono, sorry about that. This could be mono oxide, or in other translation, this could be monoxide. We can actually opt out the next O. Okay? Dihydrogen monoxide. Ito, remember, the prefix mono may be omitted for the first element. Now, if ever po na mono ang unang gamitin dito sa unang element, pwede na po nating hindi gamitin. Okay? In oxides, the ending A in the prefix may be omitted in some cases. For example po, itong pentaoxide can be written as pentoxide. Ito yung ibig sabihin nitong number 2. Pwede, may be omitted. For example, ang ginamit mong prefix ay penta or hexa, okay? Pwede na siyang pentoxide. For example, ito oxygen ang ginamit. So, pwede na siyang gawing pentoxide, ganyan. Okay? Or pentaoxide. Either way, it's possible. Examples, ito, phosphorus trihydride. Dapat itong pH 3 mo, monophosphorus trihydride. Pero dahil nga pwede natanggalin si mono sa una, again, una lang pwedeng tanggalin si prefix na mono sa una, pwedeng phosphorus trihydride na. Okay? Ito naman, dinitrogen trioxide. Okay, dinitrogen trioxide. Ito naman, carbon monoxide. Hindi na siya tinawag na monocarbon monoxide. Pwedeng tanggalin si mono. Okay? Ito, monohydrogen monoiodide. Again, tinanggal na din yung mono kasi nga pwedeng tanggalin. Ito ay sulfur dioxide and then sulfur hexachloride. Okay? Alright, more examples para mas lalang ma-practice. So, examples, CH4. So, CH4, following the format, so I can write monocarbon. 4 is a prefix, tetra. So, that will be tetra, CH4, tetrahydride. Okay? I'm just following again the format. Next one, NH3. So, monocarbon tetrahydride or carbon tetrahydride. Pwede po yan. It's either may mono or wala. How about NH3? So, I can write it as mononitrogen trihydride or nitrogen trihydride. And then last one, H2O. I already gave the answer for H2O, but nonetheless. So for H2O, I can write this one as dinitrogen monoxide. Dinitrogen monoxide. Okay? Okay. So I hope you got a thing or two from this particular topic. Next video, I'll be discussing more chemical nomenclature for certain particular substances. Okay? Thank you for tuning in, and I hope you learned a thing or two. Have a great day.